Okay, LeetCode problem 121. Best time to buy and sell stock. You are given an array prices, where prices with the index of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. You cannot achieve any profit. If you cannot achieve any profit, return 0. Alright. So what we want to do is buy and sell. So we need pick two numbers. Our first number will be our buy, our second will be our sell. And I don't think you can go backwards. No, okay, so first example, we have 715364. Our output is 5. So buy on day 1, or day 2, where the price is 1, and then sell on day 5, where the price is 6. Profit is 5. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. Alright, prices 76431. Output is 0. In this case, no transactions are done and a max profit is 0. So example 2, you can't get profit because it's decreasing as you move. Okay, so we can do 2 loops, for loops, a for loop and a for loop. We're gonna need an integer to keep track of our max profit. We probably want to also compare while we're looping. So we're gonna have a current price and a current profit and a max profit. So we need to buy and sell. So we're gonna do an I and J, compare, and then we will be resetting our max profit if we come across a number that's greater than our current max profit. Alright, so first things first, let us set our max profit, and then this is what we're also going to return. So setting it to 0, because if we can't achieve any profit, we're going to return to 0 too. So that takes care of that. So now we want to loop through our prices. Oh, come on. Prices that count. Alright, and then we're gonna loop through that with a J. So that's gonna get us our second number for J, and it's gonna be I plus 1. So we're gonna do I plus 1. And we're also gonna still do our prices that count. That's our barrier. Okay, so for this, we want to subtract our second number from our first. So that's going to be our profit. So let's make a new variable for profit. So that's going to be prices, our J. So this is going to be our sell minus prices I, which is going to be our buy-in. So our buy is our first. Our sell is the second, but to get profit, we subtract our sell-in from our price, our buy price, and then this is where we'll do our comparison to set our max price. So if our profit is greater than our max profit, then our profit becomes our max profit. our max profit becomes what value our profit is at. So like this, if profit is greater than our max profit, then we just assign our profit to our max profit. And that should be it. So we're doing 2 for loops. So time complexity is going to be n squared for sure. So we have our first number. Then we try and get our second number. And then we subtract our second number from our first number. If it's greater than our max profit, then we set that new number to our max profit, and then we go again. We're just going to loop through all of them. Okay, let us run it and see. Okay, all test cases pass. Let's do some submitting and see what we get. Time limit exceeded. So we're taking too long. So that means on a big set of numbers, how can we improve this? The first thing we can probably do is get rid of the 2 loops inside of each other. That always makes it more, it always makes it take longer. How do we do that? What loop can we get rid of? So we have max profit. We need to keep that. Okay. So this checks every possible selling. This checks every number. 7. Or should we just use the first number? Okay. Let's do this. And then we're still going to use a for loop, but we just need 1. And then we can check our current price, which would be I minus our first price. So that's our current, and then we can just check our max profit against that. We'll set our max profit to let's use the biggest between our I between our current and then our max profit, our old max profit. So if that's it, we also need to update our first price the same way. So we can do, okay, the naming is pretty bad for this because it's not going to be first price anymore. It's just the first price we checked, but we're going to update this the same way. So we have our max and then we'll have our minimum. So this will be first price. And we also use y. And then we return max profit the same. Okay, so what are we doing here? So our first price is the first price of the day, so that would be 7. Max profit is still 0. We're going through the prices. So we're saying our current price is our current price and the smallest number we've seen so far. And then our max price would be, if we, at this point, if we've seen any bigger profit. Then we check if our current price is lower than our first price, that's our new lowest price, and then we just return the max profit. Okay, let's see if this works. I mean, the first one worked. It just broke when we tried the bigger numbers. Okay, this one is much better. It passes all of the tests. Okay, so let's look at some of the solutions. 100% faster solution. If buy prices, what else? Okay. I think they're going to similar what we were trying to do with the 2 loops. Single greedy pass approach. This solution attempts to go through the price list just once while keeping track of the minimum buy price encountered so far. Okay, yeah. The same, start by setting a minimum price for the first place. Traverse through each. Yep. That was perfect. This is a crazy map. I'm trying to get a solution and be able to explain it. Stocks cannot be sold before buying. Yep, so track buy and sell prices and variables set to -1. Current price, let's set that. Okay. So yeah, they're also doing that 2 variables setting. Okay, that is LeetCode problem 121. Best time to buy and sell stock.